and we discuss first three layers, upper layers, application layer, presentation layer, and session layer. Okay, and the remaining is your transport layer, network layer, data link layer, and physical layer. We'll see today. So transport layer. What is a transport layer? Before you go to the transport layer, so I have to add one point here. So that is called a PDU. PDU. What is PDU? Okay. What is a PDU? Means packet data unit. Means each layer, there is a data, right? There is a data in the each layer. Okay. Whatever the format it is, data is, it can be an encrypted format, or maybe it is in ASCII format, it is compressed data, whatever it is the data we call it as in the layer data, each layer data is PDU. Okay, so common name is PDU, packet data unit. Each layer transfer their PDU to another layer, like a application layer data to presentation layer, presentation data to session layer. So these PDUs are transferred from one layer to another layer. So same thing, the session layer up to session layer PDU is transferred to transport layer. What is this transport layer will do? Transport layer will provide a end-to-end connectivity. End-to-end connectivity. Provide a end-to-end connectivity. How it is provide end-to-end connectivity, we'll see that one. And transport layer do segmenting. What is a segment? Means making a pieces. For example, I have a message called a hello, how are you? Just for example, guys, only for understanding. Really, it won't happen like this as per this example. Okay. So just for our understanding, I'm telling this example. Okay. It will segment the data. You don't follow any spaces kind of stuff. Already I told for understanding purpose. It segment the data. It means it cut the data into small pieces. Okay. So minimum size is 64 bytes to 150 bytes. So 1500 bytes. That is the each piece size. Okay. So it segment the data in numbering and sequencing the data. So it put a numbering in the sequence order. For example, just for example, 1 by 4, it's a 2 by 4, 3 by 4, 4 by 4. So it is numbering and sequencing on the data. Okay. What is the use of this one? Guys, if you send an entire packet, if you send this entire packet at a destination, something problem is occur. For example, instead of hello, how, something like this, it is received. So destination check the data and okay, data is not in good format, it will drop the packet. And destination does not send any acknowledgement. Okay, no acknowledgement means source think destination is not received. Again it will send. Second time it is got like this. Like this. Something missing here. Again data is corrupted. Or data, some part of data is missing. So destination drop the packet. It does not send any acknowledgement like I received a message kind of stuff. It does not send. Again source has to send. Like a source has to keep sending data to the destination. Okay, so destination will give acknowledgement once it is received 100% data. Okay, no errors kind of stuff. So this is what I trying to say it is. So that's why what it will do, it try to cut the data, small pieces of data will send. small one by one piece of data is sent. For example, I will send first one. Hello. Sorry. I will send first one. Destination received. Yeah, first one I received. Then it send an acknowledgement. Yes, I received this packet. Okay. This packet number is received. Then source send second one. Destination received. Then it send an acknowledgement. Source understand. Yes, second one is received. Then send a third one. Third one is not received. Then it does not send any acknowledgement. Meanwhile, it is send fourth one also. Fourth one is received. So what is happened here? I received a first one, second one, and fourth one, but not third one. So if I put a data like this, so hello, how you? This is received. Third one is not received, so that is error. And source understand only this part is missing. Then source again send third one. Now third one is received and it send an acknowledgement for third one. Yes, I received a data. Now R is missing, that is all R is also added. Now full set data is received at a destination. But there is a problem. What is the problem? R should be here, right? 1, 2, 3, 4. But third one is went at end, right? Again it will put it in a order. Again it will put it in a order. Right? So this is called a numbering and sequencing. That is a numbering and sequencing. So in a sequence order, data is arranged even after it cut into the pieces, it arranged in the data in the sequence order, numbering and sequencing. It is useful for a error correction. Whenever the destination received a packet, which packet is not received, again, based on the acknowledgement source understand, so it will send the missing or dropped packets again. So once destination received all the packets, it rearranged the packets as per the numbering and sequencing. So this is, we call it as a transport layer do error correction. This is how it will do error correction. Okay. So segmenting, numbering and sequencing. It multiplex and demultiplexing of TCP and UDP protocols. Normally, when people are learning about TCP UDP, they learn difference between TCP UDP. Okay, they learn about TCP and UDP differences. But what is this TCP, guys? We know the protocols, we have seen the protocols and their port numbers, right? So we'll look at once again, these are the protocols. Some of these protocols are TCP type protocols, some are UDP type protocol as well. For example, you take HTTP protocol. HTTP protocol is a TCP type protocol. The type of protocol is TCP type protocol. Okay. If you take FTP, FTP is also TCP type protocol. TFTP is a UDP type protocol. DHCP, UDP type protocol. DNS, UDP type protocol. SMTP, TCP type protocol. Okay. So we have a different protocols while you are communicating, but certain protocols are TCP type, certain protocols are UDP type. Some protocols are both TCP and UDP protocols. Okay, if you want to search, you can search also TCP, UDP protocols. Okay, it is give other things, but I need a list. Okay, it is given some common protocols. So as what we discussed, that one only it is given exam collection. Okay. No. We don't want that one. So protocol port number list. See this? DNS, TCP and UDP type, DHCP UDP only, TFTP UDP, and HTTP TCP. So Pearson IT certification.com, some duplicate website it is. Okay, see, this is a TCP type protocol. FTP is a TCP type protocol. SSH TCP, Telnet TCP, SMTP TCP, DNS TCP come UDP, both it will use. Okay, UDP type protocol. This is UDP protocol. TFTP UDP protocol. HTTP TCP TCP. NTP UDP protocol. Network time protocol is a UDP protocol. NetBIOS 139, 138, 139. Okay, TCP. This is SNMP TCP UDP type. Okay, LDAP TCP UDP type. HTTP STCP again. Okay, LDAP S it is secure. Okay, and FTP or SSL again TCP type. So like that, very big list is there. It is given as some kind of list it is. Okay, so certain protocols are TCP type protocol and some protocols are UDP type protocol. NTP also comes under UDP. DNS is comes under both TCP and as well as UDP also. Okay. So what is this TCP type and UDP type? It is a protocol behavior. Okay. It is acknowledgement based protocol. You're sending a packet to source to destination. You send a packet to destination. Destination received a packet and it will send an acknowledgement. Okay. Yes, I received a packet. So same thing, source send a packet, destination received a packet, destination give acknowledgement. Source send a packet, destination does not receive a packet, no acknowledgement. So the source understand this third packet is not received by destination. Again, it will send this third packet either immediately or in a sequence again. Okay. So once it is saying I received a third packet through acknowledgement means yes, source understand destination is received. That's why it is acknowledgement based protocol, first one, and it is reliable. It is also called as reliable connection oriented protocols. Guys, again, lot of mistakes people believing because of names. Okay, and explanation. So people try to put some examples for that. Connection oriented. Connection oriented means source and destination maintaining a connection here. Source sending, destination received, and destination will send an acknowledgement to the source. Source knows destination is received or not. That's why it is reliable protocols. These protocols, TCP type protocols, are reliable protocols, connection oriented protocols. It does not mean wired or wireless. If you are, I'm connected with a wired now. So yesterday I connected wirelessly, and now I'm connected both wired and wireless. Yesterday it is wireless network, but I open HTTP. Okay, I open HTTP, FTP, everything I can able to open. So it is not about a wireless or Wi-Fi kind of stuff. It is completely wrong example. Connection oriented means, for example, I am talking, do you understand? You said yes or no, or you asked some question. So are you able to see my screen? You said yes or no. Means I can understand, yeah, you received a information or not. So that is connection oriented. For example, I'm keep talking. Do you understand? No reply. I've tell this one. I send data. I send all packets. I send data. I given all messages. But you are not received or not. I don't know. You didn't given a reply. Morning, for example, morning I said 10:30 class. Immediately some people said, no, okay, sir. What is the link? Messages. So then I will understand. People see the message, so they can able to connect it immediately. So I have to hurry to connect first, right? So I understand you received information. A blue check marks. So what is the check mark part? If we received a data, this is a check mark. Right? You received, I sent is completed, received, then read. Right? Same way it is. Source knows destination received or not because of once destination received a packet, a destination send an acknowledgement to the source. That is why it is connection oriented. What is the UDP type? We have a source and destination. You send a packet, destination received, you send a packet, destination, you send a packet, you send a packet, you send a packet, you send a packet. But see, there is a packet is missing, packet is not received here. But source does not know whether destination is received a packet or not. We have to keep sending packets. That's it. We don't know whether destination received a packet or not. So this is no acknowledgement. So we don't use any acknowledgement to acknowledge I received a packet. It is non-reliable protocols because of source does not know destination received a packet or not, and also called as a connectionless protocol. Also called as a connectionless protocol. What is connectionless protocol? Because we are sending, other side received or not, we don't know. Okay. Again, see, this is you guys become a connectionless now, or what? UDP type or a TCP type protocol? What is TCP? Transmission Control Protocol. UDP, User Datagram Protocol. Same data is there here. TCP, UDP. Guys, understand TCP UDP difference? What happened today? Class is going on fine, right? Yesterday's problem, but today is going on fine. People should tell yes or no because you know already my system has a fallen. I don't know. I am connected, disconnected, application working, not working, able to hear or not. If you
Yes,
don't have
sir. Can
interest,
you sir give an example
which
like
one?
for the TCP and UDP? The examples sir, for the TCP and UDP.
Yeah, these are protocols are TCP type and UDP type protocols. 1 second, I will check.
So can you sir please like retell the difference between the HTTP and HTTPS? Earlier sir you said before
Yeah, I
the break.
told that one. HTTP,
Okay, sir,
HTTPS.
please sir retell.
Again, you want?
Yes sir, difference sir. Yes sir, again sir, just a little bit.
Okay, no
Summary.
problem. If you use HTTP, your data, so very easy is understand your WhatsApp. For example, guys,
Okay.
if I open a website, so a website means HTTP websites only, right? I open some website. So which one is, okay, this one is, I open a website. It is showing HTTPS, but HTTP websites are very less now, very difficult to find now. Okay, it is showing HTTPS, but if in case it is HTTP type, what will happen? Is this? This is a better. Yeah, here it is. So this data, whatever the data it is transmitting, it is in the whatever the data as it is only. Like a text format means text, picture means picture. So no encryption inside. So if anyone, like you are receiving a data from server, I am sitting there, I am capturing your data, so I can read your data also. For example, if I'm using an application called a Wireshark, so using this, we can able to capture the data.
Okay, sir. Got it, sir. Thank you.
Okay, so I can able to
Yes.
capture data. If you see this WhatsApp also telling end-to-end encryption, right? End-to-end encryption. What is that meaning? You can see data in your PC, okay, and end user also can able to see the data, right? But in between, what happened? Data is encrypted. So if anyone is capturing your data, or anyone trying to steal your data, they can't understand because of security. Okay. Yes means like we can easily tell secure. Yes means here the word is SSL. Okay. Using that SSL certificate means SSL encryption method. So it encrypts the data. HTTP plain. HTTPS is a data is encrypted.
Yes, sir. Got it.
Okay. So this is my Wi-Fi and this is my Ethernet. So it's a data is transmitting. See, source to destination, different IPs. It is transmitting data. Okay. If I refresh this one, so then again data transmission information it will shows. But most of the data, so acknowledgement, synchronization, source, somewhere destination. No, not this data. To whom it is selling, it is a google.com receiving packet. I'm receiving the packet, guys. Okay. So we don't have any directly a TCP type protocol, UDP protocol. So application data. We should know the IP address, then only we can get it. 1 second, I'll check IP config. What is my default gateway? Very good. Guys, pinging means which protocol? Ping is which protocol it use? Ping is ICMP protocol, and I'm pinging to this IP address specifically. Where it is gone? It will keep refreshes, right? So that's why it is difficult to find where I have done. What is this Wi-Fi? 59 source is okay. I'm pinging again, so I will try this one again. Ping is going on. CMP protocol. So this is I'm pinging to this one. See ping protocol. Okay, request and reply. Request reply. I'm getting. Okay. So can you see data? We can't understand because it is encrypted data. It is. What is your request and what is your reply? We cannot get it. So the data is showing like this encrypted type. Of course. Okay. And if it is a plain text type, FTP, HTTP, Telnet, this data is not encrypted data. So obviously we can able to read what data it is, what is the content in it. you can able to read it. Currently, I don't have any HTTP site. Otherwise, I can able to show you. Okay. Yes means this is SSL array. They use TLS. Okay. To encrypt your data. So while you are transmitting or receiving a data is encrypted. Any HTTP data we are open. Oh, there is a data for someone. See, somewhere it will be there. This is the data we are getting. HTTP is Hypertext Transmission Protocol. Keep alive. This is for connectivity purpose, not to, does not having any data inside. This is for only getting connected. See, get method like that only, not HTTPS. It is change cipher completely secure. Okay, so that's the point. Next, guys, TCP UDP, Transmission Control Protocol, User Datagram Protocol. TCP is a acknowledgement based protocol. UDP is there is no acknowledgement. Okay, for example, I open a website like this using HTTP or a HTTPS protocol. So my server send this data to me, and my PC will send an acknowledgement to the server saying that I received a data. I received a data. Still offer is going on. Basic 6 months. Direct 6 months. Direct not 1 month. Still offer is going on 1 month. 1500. I'll try later. Okay. So when I send a request and I receive a data, so whether I am received or not, so my server knows, the server knowing I received a data, because of for each packet delivery, PC will send an acknowledgement, destination will send an acknowledgement to the source. Okay. Olden days we have this compulsory kind of stuff you send. Nowadays also we are doing, for example, you are applying for a application, some application, you are applying for a passport, you pay an amount. What you receive? You received an acknowledgement, that is you are paying, you paid this particular amount respect of this particular application, or a particular name and application number, reference number is there, right? You may apply a lot of exams also online, government exams. So you fill the form, you paid an amount, you received an acknowledgement. Later you will get a hall ticket. If in case you don't receive a hall ticket, then what is the proof? Is acknowledgement. Acknowledgement means, yes, we received your information. Okay, we received your payment, like a payment receipt type. I didn't receive my payment, that's why I'm a little frustration. Still, there is a little frustration. Okay, this is TCP and UDP type. Remaining a small one only, but very important one, of course. Yeah, video is not completed, guys. So it multiplexes and demultiplexes TCP and UDP protocol. What transport layer will do? There is a TCP box. Transport layer maintain a TCP box inside like this. There is a box. Okay, means there is a originally we don't discuss that much deep, but if you see like packet format like this. See this is a kind of format. Okay. IP address formats are there. So different information source, IP address, destination IP addresses, headers, checksum, protocols, time to live. Okay. Total length of the data, total length of the packet, flags, fragment offsets, identifications, and other kind of stuff also there. Okay. So TCP, UDP, command address. This much if we discuss, then you will get a mad also. Okay. The point is, guys, here, what is it will do? It will take in that one, so it will put a TCP box and UDP box. And what is the type of communication? You use HTTP. Then HTTP protocol comes under this TCP box. That's it. Or it is a mixture of protocols are there while you are communicating. There is a mixture of protocols. For example, there is a SMTP also there. Then TCP box contains HTTP and SMTP. And same as DNS is also I'm using. For example, like a DNS is also there. Network time protocol is there. I'm also using that one. So it multiplex all TCP type protocol into TCP box. In TCP side, UDP all multiplexing into UDP. Okay. Next, flow control. So transport layer is not completed. See, it is there, but it is a big one. That's why I given a break. Okay. Flow control. What is a flow control? Whenever you send a data, okay, to the destination, sometimes, for example, you are a 1 Gbps speed of data transmission is there. But at the receiving side, it is only 100 Mbps data port is there. Means is using fast Ethernet, you are using gigabit Ethernet. So you can send data, very high speed data. You can able to send multiple packets. You can send at a time. But at receiving end, they are unable to receive a packet. All packets cannot able to capture. So what happens? Certain packets will be dropped. Again, you have to send it again because of this mechanism. So what your layer will do, it will first understand what is the receiving capacity, receiver destination capacity, how many packets it can able to receive at this particular time. Then it will estimate first what is the capacity of destination. Based on that, it will deliver the packets. Okay, that is called a flow control. Estimate destination, receiving packet capacity at a time. Already I told what is packet data unit. So data in the each layer we call it as a PDU. In the transport layer, you have a data from your session layer. Okay, this is the data from your session layer, plus it add a TCP header. So TCP header plus data from session layer. Okay, it is called a segment. Okay, what is a segment? This segment contains your sorry, the TCP header contains about a numbering, sequencing, protocols, TCP, UDP information, means the protocol informations available in this TCP header. So this is a PDU name, data, but transport layer, data from transport layer is called a segment. Okay. So this is the TCP header format. Okay, so which is better? This is your header and data. The header contains the remaining port addresses, source port, destination port, sequence number, acknowledgement numbers. Okay, there's some other information, window size. Okay, urgent pointer, operation and padding. So these are all information in this TCP header. The total combination is segment. You received a data from your session layer that is added with the TCP header, then totally we call it as a segment. This segment is sent to the network layer. The segment is sent to the network layer. What network layer will do? Network layer is dealing with routed protocols and routing protocols. What is routed protocols? Are a logical.
Sir, header also contains MAC address.
In this one, no, we don't have any MAC address.
Okay, sir.
In this header, in TCP header, we don't have MAC address. We'll get MAC address later. Okay. Better put it here. Okay. So why it is small size only? This is also 14. Okay. Okay, network layer dealing with the routed protocols and routing protocols. Routed protocols means logical addressing, different type of logical addresses are there. So we are using IP address type. So then I'm telling only IP address, either it is IPv4 or IPv6. Next, network layer also dealing with the routing protocols, means how to reach the destination. Meaning is how to reach destination will tell by routing protocols. Routing protocols will tell how to reach the destination. So different routing protocols are dealing in a network layer only. Okay. So what is this? In this segment, the segment what we received a segment, this network header will be added to that segment. What is the network header contains? Your source IP address and destination IP address. Source IP and destination IP. And packet sent to data link layer. Packet sends to data link layer. Packet sent to data link layer. Okay, so routed protocols, routing protocols. So of course you have a routing protocol information that is also will added as a network header, but mainly just generally I'm telling network header contains source IP address and destination IP address. This network header plus segment is combinedly called a packet. So we are calling packet. The originally packet means source IP, destination IP, and your data means the segment. So totally we call it as a packet. Our PDU is packet now. This packet is sent to the data link layer. In a data link layer, what happened? Data link layer having two more layers. Data link layer having two more layers. One is LLC, logical link control. Okay, what is this LLC will do? What is this LLC will do? It will connect WAN protocols. For example, you have a router or a modem. So you are connecting to WAN communication. You are local to WAN communication. That time you have to connect with the WAN protocols. So WAN connectivity is not just normally we are telling internet means networks of network, but these individual networks are connected to another network through WAN protocols only. Through WAN protocols only. Without WAN protocol, you cannot connect it to WAN. So these protocols are PPP, SDLC, frame relay, MPLS. I will tell PPP OE. All right, here PPP OE, point to point protocol over Ethernet. What it is? Nowadays we are having a internet through general like ACT kind of internet. So they are maintaining original PPP. We are not getting direct point-to-point type of connectivity. We are getting point-to-point over Ethernet type. So we are getting a switch box over our apartment. There is a one switch box. From that switch box, they are giving a one UTP or STP cable to our home. Our home router will connect it to that cable only. So it is not a direct point-to-point communication, not a direct point-to-point communication. It is point-to-point over Ethernet. We are getting internet now. Okay. Not always, not every example is not comes. There are a lot of different ways we are getting internet. So one of the ways is this is like ACT generally use PPP OE. ACT, U broadband generally they are using PPP OE. So if you see the router settings at the router side WAN settings, you can see the PPP which type of WAN protocol means PPP OE. You can see that one. Okay. Logical link control dealing with the WAN protocols, different WAN protocols. Next, data link layer also dealing with another layer called a MAC layer, media access layer. So this is having a MAC address also called as a physical address. It is 48-bit in number, 12 hexadecimals in the MAC address. So this data header will be added to packet plus data tail will be added to your packet only. Okay. So what is the data header contains? Source MAC address and destination pack address plus packet plus CRC. What is CRC? Cyclic redundancy check. Use it to check error checking. Guys, data link layer, error checking. Data link layer, error checking. Transport layer, error correction. In transport layer, if any particular packet is missing, so destination don't send any acknowledgement for that packet. Source understand destination not received this particular packet, so then destination will send a packet again. Sorry, source will send packet again. Like that, error correction. Okay, this is error checking. Whenever destination received a packet, it verify data is good or corrupted. While transmitting a data, a lot of changes, lot of effects are there. So data may possibility data is corrupted, right? So at destination point, so they will see this CRC, they will open the CRC and check with the CRC number. There is a CRC means it's an algorithm. CRC is an algorithm. It generate a one CRC number from your data only. Using that data, using your CRC data, we have to check our data, whether data is good or corrupted. Guys, you know RAR files, WinRAR files? WinRAR.
Yes, sir.
Okay. Dat RAR files are there now. If you see these dat RAR files, you can also see sometimes if you go through the file content, if you see the content with the files, you can also see CRC value in certain things. Not WinRAR, it is .rar condition we need it, not zip files. Zip does not have other things. .rar. No, it does not contain. I have to open my own WinRAR file otherwise. CRC value. Okay, what is the advantage of having this CRC value is, I think this is CRC value, CRC 32. Okay, so what is the advantage of this one? If in case your RAR file is corrupted, so we can able to repair it. In WinRAR application, there is a repair option, so CRC value. In this one, you will get a repair option here. So you can repair this. Okay, if possible, it will repair and you will get a data. Okay, repair. You can see this option is repair. So you can go to repair option and you can repair your archive. Okay, so that is CRC. Okay, same way at destination, once this packet is received, once it is received a data, then it will check with the CRC. Check with the CRC data whether your data is good or not. Okay, this is called a error checking. What is this? The total one we call it as a frame. Total one we call it as a frame. So what is frame? It is source MAC address, destination MAC address as a data header plus packet plus CRC as a data tile. So totally we call it as a frame. This frame will send to the physical layer. The last one is physical layer. What is the physical layer will do? What is physical layer will do? So it receive the frame and convert into bit stream. Bit stream means 0, 1, 1, 0. You know that one, right? So in a binary format, directly binary format to different signal conversion. For example, I'm using a Ethernet type communication, means wired communication. So it is an electrical signal only. It is a electrical signal, wired communication, UTP, STP, copper cables. So my NIC convert the data into electrical signal. For example, in my mobile, I'm using Wi-Fi. So, and I'm sending and receiving data through Wi-Fi signal only. It is called a radio signal, right? Next one is, if in case I have a very good server that is having a fiber optical connection, or maybe my router is having a fiber optical WAN connectivity. So how data is converted? Data is converted into light waves. The data means the bit stream is converted into light waves. Depends upon your media connectivity. So the physical layer convert data in frame into bit stream to that signal. Okay, this is finally your OSI layers. Okay, guys, anything understand or something understand, totally not understand?
So something understand.
Okay. Okay, so always practice one by one: application layer, presentation layer, transport layer, network, and next one. Okay, so here I have a source, means my PCA system is there, and destination as a PCB system is there. Now I want to send a packet and I will receive a packet. So we'll see how it is happens. Click it here. Application layer means I open a browser, or maybe I'm doing pinging, okay, from my CMD. So this is the roles of your application layer, right? Application and protocols. What is your request kind of stuff will deal by application layer. I am sending. I am a source. I am sending something. Okay, application layer. Then packet is go to the data, go to presentation layer. At presentation, data will be encoded, compressed, encrypted. Now the presentation layer data is sent to the session layer. Session layer add session ID to the your data. Now that one is sent to the transport layer. Transport layer take the data, cut into the small pieces called as segmenting, and put a sequence numbering on it. Okay, so sequence and numbering on it. What kind of protocols you are using? TCP type protocol or UDP type protocol, multiplex, TCP UDP protocols. And transport layer also understand what is destination flow control mechanism, that is also added here. And finally, there is a TCP header added to our PDU, our data. So that is called a segment. This segment sent to the network layer. Network layer add a source IP and destination IP to our segment. Okay, source IP means PCA IP address, destination IP is PCB IP address to our segment. Then it is become a packet. This packet as a PDU will send to the data link layer. Data link layer is add source MAC address, means PCA MAC address, PCB MAC address to the our packet plus CRC, cyclic redundancy check. That algorithm generates a data from your data only to check the data is good or corrupted. Okay, so that is called totally called a frame. This frame is converted into this frame is sent to the physical layer. It converts into the bit stream. For example, I am using wire communication, means electrical signal. So my PCA is connected to PCB through electrical signal, through cable. Data is sent to the PCB's physical layer. Okay, so physical layer received a data, received a information from PCA and check the bit stream, convert bit stream into frame. And this frame is sent to the data link layer. Data link layer open the frame, understand source MAC address, destination MAC address and CRC. So source MAC address here means PCA MAC address is there, PCB MAC address is there, and check it is my or not. Okay, it is mine or not, like that. Next CRC, it will open the CRC and check data is good or not. Data is corrupted or good. Now, yes, data is good. Then it extract the packet. It extract the packet. Small bit I'm adding here, guys. At PCB. So first of all, at PCB, received a packet, right? So what I received, source MAC address. Source MAC address I received. Keep it aside. Next. So I extracted a packet. So the packet sent to the network layer. Network layer open the packet, check the source IP address. Source IP address means yes MAC address, yes IP address is there, and B's IP address is there. So what it will do? If these IP addresses belongs to me or not, it will check. Yes, it is belongs to me, then it will accept the packet. It is not belongs to it, then it drop the packet. So source IP address, destination IP means PCA IP address, PCB IP address plus segment is there. So what network layer will do? Network layer extract the segment, send the segment to the transport layer. Transport layer line up entire segments based on their sequence numbering. All the segments will be layered and demultiplex this TCP UDP kind of stuff and arrange the data packets into proper order in transport layer. And finally, the transport layer, the data will give it to the session layer. Session layer check the session ID and store the session ID and send to the presentation layer. The presentation layer will verify. Okay, first of all, it encrypted, right? So it is a decrypt here. In presentation layer, data is decrypted. Decompressed data is decrypted, decompressed, and decoded. So finally, we got a our data that is sent to the application layer. So application layer will decide how to present the data, what is your PCA request or PCA data. So do process according to that one. Again, from PCB to PCA, reply is there, for example, then application layer from PCB again while PCB to PCA, again application layer, presentation layer, session, transport network, data link, physical layer, and physical to physical, and physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, so like this, communication will happen from top to bottom or bottom to top. Okay. Okay. So why I've written like this, guys? So whenever we received a packet, in that packet there is a MAC address and an IP address, right? So in our system, in the disk system, we'll map this IP address to MAC address. Okay, that is called a ARP table. Have you seen this ARP space hyphen A? ARP space hyphen A. So whenever you received a packet from system, okay, so it will note down their IP address and MAC address as a map. So it is useful for a communicate again. Okay, it is a map. Using that map matches, it communicate. Okay, so I'm reversely have to write. This is source IP means ABC IP address. It maps like this. When you receive ABC IP address and APC MAC address. So this is a ARP table. APC IP address, APC MAC address will not. Command is ARP space hyphen A to list. Command, right? This is the command, this is the details. So list ARP table. Of course, you can create ARP table manually, and so I will show you that one in bottom. So ARP, so like this. Okay. So like this, we can add statically also. Why we are adding statically? For security purpose. We use this MAC address, IP address bindings in a secured, more secure required places. Means whenever you received a packet, the MAC address and IP address matches, then only accept the packet. Otherwise, discard the packet. Only like I can send a packet with a different MAC address, right? Different IP address. So you received and you will may get a call. So in secure location, I will accept the packet from source only if the source PC MAC address and IP address matches. I will accept. In that cases, we'll add statically also. But what is ARP table? It is a map. Maps, IP address and MAC address. So to check the ARP table like this. Okay, so as a part of that one also I told guys, this is how your OSI layer will work. And as I said in morning, that is some more points. So we have to discuss still IP address is there and troubleshooting with OSI and ping also there. Okay. That is it for today. I hope you understand at least somewhat. But just
Yes, sir, got it.
read once again.